In mid-1944, a civilian technical representative named Charles Lindbergh steps off a transport aircraft onto a coral airstrip in the southwest Pacific. United States Army Air Forces units there fly the Lockheed P-38 Lightning, a twin-engine fighter with 450 caliber machine guns and a 20mm cannon mounted in the nose. Pilots respect its concentrated firepower and high-altitude performance, but they complain that real combat radius falls far short of the theoretical numbers in the manuals when they have to escort bombers deep over water and still keep a reserve of fuel. Standard practice in the theater pushes safety first. Most pilots cruise with relatively high propeller RPM, comfortable manifold pressures, and the mixture controls set to auto-rich, for fear that leaning too far might trigger detonation and ruin an Allison V1000, 710 engine in seconds. The doctrine is conservative, and it works, but it burns fuel faster than planners would like. In briefings, Lindbergh listens watches where pilots set their throttles and mixture levers, and quietly begins to compare their habits with the long-range techniques he used on his own record flights years before. When he starts flying with P-38 squadrons such as the 475th Fighter Group, he tests a different combination in the Lightning. Instead of holding the usual high cruise RPM, he lowers propeller speed to around 1,600 revolutions per minute, keeps manifold pressure relatively high to maintain power, and uses the auto-lean setting in conditions where the engines run smoothly. In level flight at modest indicated airspeeds, the engines stay cool and steady. Fuel flow drops well below what pilots are accustomed to seeing, yet airspeed and altitude remain acceptable for long over-water legs. Over a series of missions, the pattern repeats. Where other P-38 seconds return to Hollandia or Biak with tanks nearly empty, Lindbergh's aircraft lands with noticeably more fuel remaining. Calculations based on these flights show that used correctly, the new settings can increase the P-38's operational range by roughly half, while still keeping a reserve for diversion and emergencies. The Lightning's impressive range was always built into its structure and its fuel system. The difference is that now pilots are actually reaching that potential in combat conditions. Lindbergh writes down his recommended power settings and fuel planning figures and passes them to Group and 5th Air Force officers. Mechanics and operations staff reproduce the notes for briefing rooms. At first, many pilots regard the civilians' advice as risky theory, but repeated missions with greater fuel remaining and successful long-range sweeps begin to change minds. Without altering a single structural part of the P-38, one civilian's supposedly impossible way of running the engines has made the Lightning far more dangerous across the southwest Pacific. It can now fight effectively at distances that had seemed out of reach only weeks before. By the middle of 1944, the long legs of the P-38 are already well known in the southwest Pacific, but they are rarely used to their full extent. Escort missions are planned with wide safety margins. Fighters are scheduled to turn back early so that no one runs a tank dry over empty ocean. Pilots accept this as an iron rule of operations. After Lindbergh's arrival, the picture begins to change. On early sorties from fields in New Guinea, he flies on the wing of experienced leaders from the 475th Fighter Group. At the briefings, he listens to the fuel figures, leans over maps with the planners, and quietly proposes different power settings for the long cruise legs to and from the target. In the air, he proves that the combination of lower RPM, higher manifold pressure, and auto-lean mixture can hold altitude and position while burning significantly less fuel than the group is used to seeing. Mission reports start to show the pattern. On flights from Hollandia and later from Biak to targets in the Halmahera and Seram areas, P-38 seconds using the new settings return with more fuel in their tanks than the old plans would have allowed. Pilots who once expected to spend only a short time over the objective now find they can remain with the bombers longer and still land with a safe reserve. Group staff officers do the arithmetic and realize that under the right conditions, the operational range of the Lightning has increased by roughly half. The change filters through the squadrons in a practical way. Lindbergh writes down recommended cruise combinations and fuel allowances. Operations officers and engineers copy them into briefing notes and paste them into logbooks. In dispersal areas, ground crews hear pilots talk about arriving back with more fuel than before on the same routes. New arrivals to the group take their seats in hot, crowded briefing tents and find that the long-range settings are already part of the standard talk before takeoff. Both the targets and the routes begin to stretch. Long sweeps that once sat on the edge of what planners dared to schedule become routine tasks. Fighters can now accompany medium bombers deeper into Japanese-held airspace and still cover them on the way out. When Lindbergh flies the 1,200-mile sweep to Palau with a small formation of P-38 seconds, it demonstrates in dramatic form what the new way of running the engines can achieve on real operations over open water. To the pilots, the difference is felt not as a sudden miracle but as a quiet expansion of their world. The same aircraft with the same engines and tanks now carry them hundreds of miles farther from their bases, with greater confidence that they will return. The impossible combination of low RPM and lean mixture ceases to be a rumor and becomes part of daily practice. In the Southwest Pacific, the turning point is not a new model of fighter, but one civilians' insistence that the engines they already had could be trusted to take them much farther than they had ever dared. By the middle of 1944, the fuel-saving methods that Charles Lindbergh demonstrates are no longer a curiosity used on a few experimental flights. At Hollandia, and then at Biak, operations officers in the 475th Fighter Group and other P-38 units begin to build their daily plans around the new cruise settings. The long range that had existed on paper now appears in the arcs drawn on the wall maps, pushing deep into Halmahera, the Celebes, and the southern approaches to the Philippines. In briefings, the changes are simple but precise. For the long over-water legs, pilots are told to pull their propeller speed back to around 1,600 revolutions per minute, hold relatively high manifold pressure to keep power and select auto-lean mixture once the formation is settled at altitude and out of immediate danger. These are the combinations Lindbergh has flown himself and explained in detail. Tests and mission experience show that at these settings, a late-model P-38 can reduce its fuel flow to roughly 70 gallons an hour for both engines in cruise, extending practical endurance by several hours compared with the old high RPM auto-rich habit. The pattern appears in the mission records. Escort and sweep flights from Biak to targets around Halmahera and beyond return with fuel reserves that would have been considered impossible only months earlier. Some sorties match the 1,200-mile round trip to Palau that Lindbergh flies with a small formation from Mokmer Drome, demonstrating that the theoretical 9-hour endurance figures derived from the new cruise technique have real meaning over open ocean. Under favorable conditions, planners now treat a combat radius of 600 to 700 miles as attainable for lightning formations that manage their engines correctly. This alters the tempo of the campaign. Where planners once had to stage fighters through intermediate strips to cover bombers, they can now send P-38 seconds directly from major bases to distant targets and home again in a single day. Medium and heavy bombers of the 5th Air Force strike airfields, harbors, and supply points that had previously escaped regular fighter escort. Japanese units find that Allied fighters can appear above their bases or convoys at ranges they had judged safe. The tactics of the Southwest Pacific shift, without any new airframe appearing on the ramp. It is the way the existing engines are run that pushes the front line outward. To the men who fly and service the aircraft, the change feels incremental rather than dramatic. Fuel figures in logbooks creep upward, while abort rates for low fuel creep downward. Maintenance reports show that engines operated at the recommended lean cruise settings remain within temperature and wear limits. Over weeks and months, the cumulative effect becomes clear. The P-38, already feared for its climb and concentrated firepower, has quietly become a far more dangerous weapon across the theatre because one civilian has shown its pilots how to reach battles that had previously been beyond their horizon. By late 1944, the fuel-saving methods that Charles Lindbergh demonstrates are no longer confined to a handful of crews in one fighter group. Within 5th Air Force P-38 squadrons that have flown with him over New Guinea and the islands to the north pass on his cruise combinations, in briefings, in logbooks, and in the quiet conversations that shape how pilots actually to handle their engines. The impossible way of running the Lightning becomes normal practice in the theatre. Operations officers treat the new technique as one more tool to stretch what their existing aircraft can do. When they plan strikes from Biak or other forward bases, they assume that crews will use low RPM, high manifold pressure lean mixture crews on the long legs over water. Combat radius figures that once belonged only in factory pamphlets now appear in daily operations orders. Missions that would have been rejected as too risky for fighters a year earlier move onto the schedule. The change is most visible in the way planners think about distance and time. Fighter sweeps and escort runs can be drawn deeper into Japanese-held territory with confidence that the P-38 seconds will still have fuel to loiter and fight. Commanders can assign lightnings to cover bombers against targets in the Halmahera region, in the approaches to the Philippines, and on long reconnaissance routes over the Banda and Molucca seas, knowing that the same airframes and engines will bring their pilots back. Within the units themselves, the adjustment feels practical rather than dramatic. Pilots compare fuel remaining after similar missions flown under old and new methods and quietly adopt what works. Ground crews note that engines operated according to the recommended cruise settings stay within temperature limits and continue to meet expected overhaul intervals. The long-range potential of the P-38, once something most men only read about in manuals, becomes something they experience on ordinary sorties. In this corner of the war, the effect of one civilian's work is measured not in new hardware rolling out of factories, but in the arcs on a map and the fuel left in a tank. The same twin-boom fighters that had already earned a reputation for speed and concentrated firepower now reach farther, stay longer, and appear over targets that Japanese forces believed lay beyond their escort range. Without changing a single major component, Charles Lindbergh's impossible trick turns the P-38 into a far more dangerous weapon across the Southwest Pacific. By the end of 1944, the results of Charles Lindbergh's experiment are easiest to read in the small numbers that fill out 5th Air Force records. Escort missions that once sat near the limits of what planners dared to schedule now fall well within reach. Long-range sweeps from Biak and other forward strips strike airfields and harbors around Halmahera and the northern approaches to the Philippines with regular fighter cover, not just bombers flying alone. The Lightning's extended reach is no longer an exception. It is built into the way the theatre fights. In P-38 revetments, the difference shows up in the fuel figures chalked on clipboards. Pilots who have flown both the old high RPM auto-rich cruise and the new low RPM high manifold pressure lean mixture technique compare notes and quietly shift their habits. They know now that if they treat cruise as an engineering problem rather than a superstition, the same airframe will bring them back from targets they once considered beyond escort range. The impossible combination that Lindbergh first demonstrated no longer feels like a gamble. It has become part of standard airmanship. For operations officers, the trick means more options every time they unfold a map. Fighter coverage can be promised over convoys running through exposed sea lanes and over bombing raids aimed at outlying Japanese bases that had previously been left to fend for themselves. Reconnaissance lightnings can be sent on long arcs over the Banda and Molucca seas and still be expected to land with fuel in hand. Without adding a single gallon of capacity, the planning radius around each forward base has swollen outward by hundreds of miles. On the Japanese side, the change is felt as a gradual tightening rather than a single blow. Fields that once saw Allied fighters only rarely now hear the distant note of P-38 engines more often. Supply routes that were once checked only by bombers at the edge of their range now face interception by fighters as well. A machine the Japanese already respected for its speed and concentrated nose armament now appears in places where their own calculations once said no escort could follow. Inside the American units, the measure of success remains quiet and practical. Fewer sorties are scrubbed for fuel concerns. Fewer pilots vanish into the sea at the end of long missions. Engines run at the recommended lean cruise settings continue to meet their expected overhaul intervals. The Lightning's reputation changes slightly in the way men talk about it. After dark, not only a fast, hard-hitting twin-boom fighter, but an aircraft that in the right hands can reach far out, do its work, and still bring its crew home. Seen from outside, no new model number appears on the data plates, and no headline announces a breakthrough. The aircraft on the ramp look the same as they did before Lindbergh arrived. The difference lies in the way throttles and mixture levers are set for hour after hour over water. One civilian's insistence that the P-38's engines could be trusted to run lean and steady has given 5th Air Force a fighter that is dangerous not just close to its bases, but across the breadth of the Southwest Pacific. Years after the surrender, former P-38 pilots gather at reunions and still talk about the moment their world seemed to grow smaller. They remember long missions over water that once ended with needles pressed against empty, and how after Lindbergh's visit, the same routes finished with fuel still in the tanks. For them, the change is measured in quiet details: the way escort legs grew longer, the way planners stopped treating far-off targets as out of reach, and the way a civilian's handwriting on a sheet of paper altered how they thought about their engines. Many of these men later move into civilian cockpits. Airline and charter companies are quick to hire experienced wartime pilots. In peacetime, they fly transports instead of fighters, but the habit remains the same: watching fuel flow, thinking about mixture and power as variables to be managed, rather than fixed settings to be feared. They do not all carry the old tables with them, yet they carry the lesson that careful engine management can turn a hard limit into a margin of safety. Among the ground crews and officers who served with them, the memory of Lindbergh's work sits alongside other innovations that pushed the Southwest Pacific campaign forward: new bases, new tactics, new aircraft. What makes his contribution unusual is that it did not come from a factory line or a new design. It came from a different way of using what they already had. The P-38's range figures on paper did not change. What changed was that crews began to treat those figures as attainable in real operations. As the years pass, the story settles into the folklore of the units that flew the Lightning. Veterans describe the aircraft not only as a fast, hard-hitting twin-boom fighter, but as a machine that for a time could reach deep into Japanese-held territory and still bring its pilots home, because one civilian had shown them how to trust their engines differently. In their recollection, that impossible trick of low revolutions, high manifold pressure, and lean mixture is the reason America's P-38 seconds became far more dangerous than the men who first received them ever expected. Decades after the war, former P-38 pilots still find their way to restored Lightnings in museums and at airshows. They stand under the twin booms and remember long missions when fuel needles crept toward empty over an empty sea. And how, after Charles Lindbergh's time in their squadrons, those same routes ended with a margin in the tanks instead of a gamble. In their memories, the change is not tied to one dramatic day, but to a gradual realization that the fighter they had been given could do more than they had first believed. Many of them carried that lesson into civilian flying. Airlines, cargo operators, and charter companies hired wartime pilots by the thousands. In peacetime cockpits, they no longer flew P-38 seconds, yet the habit remained of treating power settings and fuel consumption as problems to be managed with care, rather than left to habit. They did not speak in public about range figures or lean tables, but when they glanced at fuel gauges on long legs, they remembered the difference between flying an engine hard and flying it efficiently. Among the ground crews and officers who served in the Southwest Pacific, Lindbergh's work is recalled alongside new airfields, new aircraft, and new tactics as one more piece of a campaign that had to be built from what was already at hand. His contribution did not change the shape of the Lightning or the numbers stamped on its data plate. It changed what those numbers meant to the men who had to trust them far from land. For a time in that theater, a civilian's impossible way of running the engines turned America's P-38 seconds into fighters that could reach deeper, stay longer, and come home more often than anyone in those units had expected when the war began.